All right, everybody, this is Dr. Tausman coming to you live from Roanoke, Virginia. Actually, this is going to be my second social psychology experiment for the day. This morning, I always wake up and I go swimming, and I go to a place called Green Ridge Recreation Center. And when I got there at 8 a.m., about 5 minutes of, there were a bunch of people waiting outside the door. And even though they were waiting outside the door, I thought the door might have already been open. So although they were doing that, I decided to walk up towards the door, and there was a button you could press to automatically open the door. I did it and let myself and 10 people in. So I violated social norms, and that led to a lot of people coming in. Right now I'm coming live to you. My daughter is shopping in J.C. Penney here in Tanglewood Mall in Roanoke. I'm sitting in the J.C. Penney lobby. I'm going to try recording a lecture as people walk by. We'll see what happens in the social psychology world of this. So the first thing I'm going to do in this presentation is kind of cover the pathophysiology of Alzheimer's disease. I have a little 3-4 minute video if you want to connect to that to watch that video. And then what I'm going to do here is I'm going to go over and describe what happens with the process using this agenda handout. What I would expect you to do is maybe copy and paste a lot of this material and then type up just little snippets in your own words where you kind of present the key, and I can see that you understand what I'm saying verbally. So hopefully you don't know anybody with Alzheimer's disease. It's a really crippling disease, but let me explain to you some of the things we know about its processes. One of the first key steps in the process of this disease is we all know that people have various chromosomes, and one of the key chromosomes we have, you may want to write this out, is chromosome 21. And that chromosome codes for something that in the diagram it shows APP, which is called amyloid precursor protein. And when people get Alzheimer's disease, something goes wrong with amyloid precursor protein. When people get Alzheimer's disease, that long protein is cleaved. It's cut by beta and gamma secretase. And by cutting it with beta secretase, that leads to the formation of beta peptides. And these beta peptides start clustering or aggregating in your brain and leads to the formation, as you can see in the drawing, of toxic plaques. So for people that get Alzheimer's disease, this beta secretase is doing that. For people who don't get Alzheimer's disease, they have alpha secretase cleaving amyloid precursor protein, and none of this stuff with beta peptide aggregating leading to toxic plaques happens. So that's one of the first things we know about Alzheimer's disease, is we get this whole pathology which leads to big spots of dead neurons called toxic plaques. The other thing that we know that happens, so actually if you look down on the drawing with C, you can see chromosome 21 amyloid precursor protein leading to the formation of beta peptide. This leads to amyloid plaques being formed. Now your brain recognizes that something is going wrong. The specific areas of your brain are the limbic system, the emotion and memory centers. If you know people with Alzheimer's disease, you know emotions and memories become really messed up. Your brain recognizes that something has gone wrong there and has the inflammatory process happens. Unfortunately, with this inflammatory process, microglia comes into your brain. They're like macrophages. Microglia comes in, it tries to destroy the big spots of dead neurons, but unfortunately, it only starts destroying healthy neurons. So this amyloid is forming, the microglia is trying to destroy it, but unfortunately the microglia destroys acetylcholine neurons, and it also doesn't destroy, but it actually enhances glutamate activity, which further complicates life for Alzheimer's disease. The other thing that occurs is on the other side of the equation, after the inflammation process, you have another chromosome there. It's called chromosome 19. And chromosome 19 codes for something called apolipoprotein E. Apolipoprotein E. There are 4 types of E proteins. First, let me explain apolipoprotein E2. When E2 is expressed, what basically happens with the neuron is E2 allows the neuron to keep its structure intact. I don't know if any of you have ever watched Star Trek The Next Generation, which is one of my old favorite shows, but if you watch that show and the captain says, or the engineering guy says, we have a warp core breach, structural integrity is being impaired. That basically means that the ship is about to blow up when you lose the structural integrity. So the analogy going back to Alzheimer's disease is when E2 is expressed, nothing goes wrong. The neuron gets to keep its shape. But when people get Alzheimer's disease, apolipoprotein E4 is expressed. And when E4 is expressed, if you look back at the picture, E4, when it's expressed, will basically cause the neuron to crumble. E4 is supposed to work with microtubule associated protein and tau protein, and when E4 is expressed, basically the tau protein won't bind with the microtubule associated protein. The neuron crumbles and we have the formation of plaques. So that is what goes wrong when you have Alzheimer's disease. You have these plaques and you have these tangles. So with that being stated, I'll stop this recording here and then get into treatments that have been tried.